In lesson 2.5, we will be looking at parallel and perpendicular lines in hopes that you will have a good understanding of them prior to starting to solve problems. Here is just some examples with the terms. These lines are obviously not parallel. These two here are parallel. And if you think about what that means, will these lines ever touch each other? Will they ever intersect? And the answer is no. Down here, we'll be looking at perpendicular. This one on the left, that is not perpendicular. On the right, that is an example of perpendicular. Perpendicular means that two lines will intersect and form exactly two right angles. And if the line were to continue through, then we would have four right angles. So if lines are perpendicular, they form right angles. If lines are parallel, they will never intersect. Looking at parallel lines, these parallel lines will have the same slope. And remember that they never intersect. So if you think about how parallel lines look, it makes sense that they would have the same slope because they will never lean into each other in order to cross. Let's look at an example. Here we have a line, y equals 2x plus 1, and we want to find the equation of the line that is parallel to that and passes through the point 5, 4. So here I've dashed in a sample line that looks like it could be parallel to y equals 2x plus 1. So I want to find the equation of this line that goes through this point 5, 4. First thing is to determine the slope of our line y equals 2x plus 1 because we know that parallel lines have exactly the same slope. Well, if I look at this equation, y equals 2x plus 1, I can see that the slope of that is 2. So the number in front of the x, remember, is your m, and that is your slope. You can also find it visually by picking a point, and I'll pick this point right here on the y-intercept, and I will count up 1, 2, before I can go over 1 and hit the line on another point. So my slope is definitely 2 over 1, or just 2. Second thing, in order to find the equation, is since we know a point on the second line, which is 5, 4, we can use our point-slope form to find the equation of this line. We can also use SlopeIntercept, but point-slope is set up nicely to plug in a point. So let's put the point 5, 4 into the point-slope equation of a line. And if you've forgotten it, here is the equation of a line in point-slope form. We have the difference of our y's equals our slope. Notice here's our slope that we identified as 2 times the difference of our x's. Now let's put in the point 5, 4. 5 is an x and 4 is a y. So, and they're both positive. So I'm going to put my x, or my y, sorry, in here. Y minus 4 equals my slope of 2 times x minus 5, and I went ahead and plugged the 5 in for my x. All right, let's put it all together. Let's put it in slope-intercept form so that it looks like the other equation and it's easy to follow. So in order to do that, you have to remember the distributive property. We have our 2 outside here, and we need to distribute it into the parentheses in order to dissolve the parentheses. So we do 2 times x and 2 times negative 5. So that gives us 2x minus 10. Now we can combine like terms. What we need to do is move the 4, the negative 4, over to combine with the negative 10. So we are adding 4 to both sides. What we're left with is y equals 2x minus 6. Negative 10 plus 4 is negative 6. And this is the equation then of this line that passes through 5, 4. Notice that our slopes are the same, and that's why we put a 2 in there, but our y-intercepts are very different. The y-intercept on the blue line is 1, and the y-intercept on the dotted orange line is negative 6, but they are parallel. Let's look at another example. Let's ask ourselves, is y equals 3x plus 2 parallel to this? Y minus 2 equals 3x. The easy way to figure this out is to put this second equation in our slope-intercept form, y equals mx plus b, in order to determine what our slope is. So first, looking at our main equation, the slope is 3 and the y-intercept is 2. Okay? For our second equation, let's go ahead and change it to y equals mx plus b. So let's add 2 to both sides, and we get y equals, so these are now gone, 3x plus 2. The slope on this is 3, so right away you see the slopes are the same. However, the y-intercept is 2, which is the same as our first equation. So in fact, these two lines are actually the same line, so they're not parallel, they're the same line. So be careful about that. If the slopes are the same and the y-intercepts are the same, it's actually the same line. Let's try one more example. Let's ask ourselves, is y equals 2x plus 3 parallel to 2y minus 2 equals 4x? Same deal as last time. We are going to need to convert this second equation to y equals mx plus b form in order to figure out what our slope and our y-intercept is. So for our first equation, we can see that our slope is 2 and our y-intercept is 3. For the second equation, let's go ahead and change this. So let's move everything to the other side of y. So let's start by adding 2 to both sides, and we end up with 2y equals our 4x, and now we have plus 2. Finally, we need to move this 2 to the other side, and we do that by dividing by 2. So we divide every term by 2, and we get 2 divided by 2 is 1, or 1y, is equal to 2x, 4 divided by 2 is 2, plus 1. 2 divided by 2 is just 1. So on this equation, our slope is 2, which is the same as our first equation, but now our y-intercept is different. It's 1. So in fact, these have the same slope, but with different y-intercepts. They are parallel. The key is, look at your slopes. Are your slopes the same? Most likely, your lines are parallel. Let's look at this visually. So here's our two equations that we found, y equals 2x plus 3 and y equals 2x plus 1. Look at how they sit on the graph. Visually, they do look parallel, but we can confirm this by noticing the slopes. The slopes are the same. They're both 2. Let's move on now to perpendicular lines. So remember that we said perpendicular lines meet to form right angles, to form 90 degrees. And we're going to learn that perpendicular lines have negative reciprocal slopes, and we'll talk about what that means. So, how do we know these two lines are perpendicular? They look like they're perpendicular, but how do we know? There's two methods. The first method is just multiply the slopes together. So, in line 1, our slope is 2, and in the orange dashed line, we'll call that line 2, our slope is negative 0.5. If we multiply those two slopes together, 2 times negative 0.5, we end up with negative 1. And that means that these are perpendicular slopes. So anytime you multiply the slopes together and you get negative 1, that means our slopes are perpendicular. Okay, so that's a quick way to check. The second way is to find the opposite reciprocal of the slope. So in our first line, we said our slope is 2. We want to convert that to a fraction. Well, remember that 2 is the same as 2 over 1. In our second equation, our slope was negative 0.5. Well, that's really the same as negative 1/2. Notice our slopes. We have 2 over 1, and then we have negative 1 over 2. Opposite means take the opposite sign. So we started with a positive, and now we have a negative, so we did that. Reciprocal means flip the fraction upside down. So if we start with 2 over 1 and we flip it upside down, we get 1 over 2. So in fact, these two fractions are opposite reciprocals of each other. So an easy way to remember that is both the slopes have to have opposite signs from each other. They both can't be positive and they both can't be negative. And you can see this visually from the graph. You've got the blue line, which has a positive slope as you walk, you're going up. And the dashed orange line has a negative slope as you walk, you're going down. So they always have to have opposite slopes. And then we always will take the slope, flip it upside down, and then that should give us our other slope. So opposite reciprocal. Let's look at an example. So we want to find the equation of the line that is perpendicular to this line, y equals negative 4x plus 10, and it's passing through this point 7, 2. So I've dashed in a line that goes through 7, 2 that looks to be perpendicular to this other line. So our first step is let's determine the slope of our line that we are given. Well, the slope of y equals 4x plus 10 is negative 4. Sorry, that should be a negative 4x plus 10. Second, let's determine the opposite reciprocal of the slope negative 4, right? Because we said that the perpendicular line will have an opposite reciprocal slope to negative 4 right here. Well, the opposite is going to be positive, and the reciprocal of 4, or 4 over 1, is just 1 over 4. We flipped it upside down. So the slope of this line that passes through 7, 2, we know is going to be positive 1 over 4. And you can see that this is a positive slope versus this one, which is a negative slope, the blue line. Third thing, just like with parallel lines, since we know a point on the second line, we can use the point slope form to find the equation of this line. So let's put the point 7, 2 into the point slope equation of a line. Here's our slope, 1/4. That's the opposite reciprocal of negative 4. And let's plug in 7 for x, and we'll plug in 2 for y. Okay, so we always plug in what we know in the second spots. Finally, let's go ahead and put this in slope-intercept form by distributing the 1/4 into the parentheses. Okay, so 1/4 times x is just 1/4 x. 1/4 times negative 7 is going to give us negative 7 over 4. Remember that 7 is over 1, so we just multiply straight across. 1 times negative 7 is negative 7, and 4 times 1 would just give us 4. Okay, we need to combine like terms. We're going to move the negative 2 to the right side, so we would do that by adding 2 to both sides. And down here is what that looks like. Y equals 1/4 x minus 7/4 plus 2. So in order to complete this, we do need to add negative 7/4 plus 2. And we do that by getting common denominators. Okay, and here's an example of what that might look like. We have negative 7/4 plus 2. We need a common denominator of 4. So in order to do that, we would multiply 2 by 4 to get 8. 8 over 4 is the same thing as 2, right? 8 divided by 4 is 2. Well, now we just need to add. Negative 7 plus 8 is positive 1 over 4. So that is the solution of adding negative 7/4 to 2. So our final equation for this orange dashed line is y equals 1/4 x plus 1/4. And you can see the y-intercept looks to be about 1/4, right? It's not at the 1 yet. And if I look between these 2 points on the orange line and I count the slope, if I start at this bottom point and count up 1, I would have to go over 1, 2, 3, 4 to hit the next point. So I know the slope is in fact 1/4, and I've calculated it correctly. So lastly, let's look at this visually. Visually, these look like perpendicular slopes, and I drew a right angle in here so that you can see, in fact, it is a 90-degree angle. But remember the 2 rules. In order to verify that they are, in fact, perpendicular, you can, number 1, multiply the slope together to see if you get negative 1. So we would multiply negative 3/2 times 2/3. Well, 3 times 2 is 6, and on the bottom, 2 times 3 is also 6. 6 divided by 6 is 1, with the negative here, so we do have a negative 1. We can also take the opposite reciprocal of one of the slopes. So if we took negative 3/2 and we took the opposite reciprocal, we would get a positive, flip this, 2/3, and that's what this is. So in fact, we have verified that these 2 lines have perpendicular slopes, so the 2 lines are perpendicular. And that concludes our lesson on understanding parallel and perpendicular lines.